Greetings everyone. My group will present about object-oriented paradigm. Our team members are Tan Ke, myself, Vilashni, anak perempuan Kumang, Ngong Leki, and Yong Zishin. A computing paradigm is a fundamental style or approach to tasks such as computer programming and software development. It serves as a blueprint for organizing data and designing systems, which guides developers to solve problems effectively. The key paradigms include imperative, declarative, functional, and object-oriented programming. Computing paradigms are essential as they provide standardized approaches and principles for computer systems, which enables programmers to develop more efficient and maintainable software. They ensure good system architecture, performance, and problem-solving techniques. Additionally, paradigms offer higher scalability and adaptability, which easily overcome computational challenges. Different models of paradigms enables developers to produce forward-thinking and maintainable solutions in ever-evolving field of technology. Among the various paradigms, we have chosen object-oriented paradigm for our discussion. Object-oriented paradigm focuses on objects, which are instances of classes that encapsulate both attributes and behavior, also known as method. This paradigm is known for modeling real-world entities and relationships, making it more understandable and relatable. The reasons for selecting the object-oriented paradigm is because it promotes modularity by dividing complex programs into manageable and reusable pieces, which improves code organization and reduces redundancy. Secondly, its structured approach supports the development of large-scale software systems, making it ideal for enterprise-level application. Thirdly, many modern programming languages such as Java, C++, and Python are based on object-oriented principles, making it a widely adopted and well-structured paradigm in the industry. Lastly, object-oriented provides flexibility in the software design by allowing developers to use polymorphism to define multiple behaviors for the same method, which facilitates code adaptation and evolution over the time.
Object-oriented programming is a programming paradigm that has two core concepts, which are object and class. The object in software refers to tangible or intangible entity in the real world, whereas class refers to a blueprint or a template which an object was created from. Both basic concepts makes writing code and developing software considerably simpler, as developers are able to write modular, reusable, and maintainable software when using object-oriented programming. Next, we talk about the evolution timeline. In 1960, the language Simula that was developed by Ole Johan Dahl and Kristen Nygaard introduced the concepts such as classes, objects, and inheritance. In 1970, the programming language named Smalltalk was developed by Alan Kay, popularized object-oriented programming paradigm and introduced many essential concepts. In 1980, the language C++ was developed by Björn Stroustrup as an extension of C language with the addition of classes, objects, constructors, destructors, and operator overloading to the language. In 1990, the programming language Java, developed by James Gosling, with his team rose to prominence in the field as it merged an object-oriented architecture with the syntax of C++. In 2000, the programming language C# was developed as an arm of the .NET platform, and it has become the main language to build the desktop, web, and mobile apps. In 2010, the programming language JavaScript, developed by Brendan H., evolved to become more object-oriented with the release of ES6, as it included the support for classes and inheritance. Object-oriented programming is a programming paradigm that has two core concepts, which are object and class. The object in software refers to tangible or intangible entity in the real world, whereas class refers to a blueprint or a template which an object was created from. Both basic concepts makes writing code and developing software considerably simpler. There are four characteristics of OOP, which is encapsulation, abstraction, inheritance, and polymorphism.
Object-oriented programming (OOP) is a programming paradigm that organizes software design around data or objects, rather than functions and logic. An object is the data field that has distinct attributes and behaviors. The process of data modeling involves combining data and functions to create objects from the data structure and establish connections between various objects. For example, a car can have attributes like colors and model, and behavior like driving and stopping. Next, there are four core characteristics in OOP, which also refers as four pillars in OOP. The first pillar is the encapsulation, which is a combination of a group of related variables and functions into a unit. This pillar restricts direct access to some of an object's component, which can help to prevent unintended interference and misuse. Think of it as a protective shield that keeps the internal state of an object safe and secure. The second pillar is the abstraction. By using it, we can manage complexity by simplifying what we work with and focusing on the relevant details. It often implemented through abstract classes and interfaces. The third pillar is the inheritance. This allows for hierarchical class structures and the reuse of code. The is-a relationship defines inheritance, where the subclass inherits the properties and behavior of the superclass. The last pillar is the polymorphism. It is a technique to get rid of code duplication. This allows methods to do different things based on the object it is acting upon, making the code more flexible and reusable. The strengths in OOP are first, code reusability, where OOP has the ability to reuse code through inheritance and hence avoid writing duplicate codes and promote code reuse. Second is flexibility, where OOP provides flexibility for programmers through a mechanism like inheritance and polymorphism. The third strength is interference-free object instances. Each object instance in OOP operates independently of other instances. This encapsulation ensures that the internal state of the object is hidden from the outside world.
The first weakness of object-oriented paradigm is lack of direct access to data, Encapsulation enhances data integrity and security by hiding the internal state of objects and providing controlled access. However, encapsulation can cause difficulties in directly accessing and modifying the internal data of objects during optimization or customization requirements. The second weakness is large memory footprints. Inheritance promotes code reuse and modularity by allowing subclasses to inherit attributes and methods from parent classes. Each subclass instance typically contains additional memory to store inherited attributes and reference from the parent class, even if not all of them are utilized by the subclass. This can lead to inefficient memory usage. The third weakness is performance overhead in terms of memory usage and execution speed. The reason is objects are created and destroyed dynamically during program execution. This involves allocating memory for the object, initializing its state during creation, and deallocating memory where the object is no longer needed. Now we make comparison between our chosen paradigm and other paradigms. The main focus of object-oriented paradigm is classes and objects. Scripting paradigm is automate specific tasks, and imperative paradigm is tell computer what to do step by step. The core concept of object-oriented paradigm is abstraction, encapsulation, inheritance, and polymorphism, while scripting paradigm is give the computer step-by-step instructions on how to accomplish a task, and imperative paradigm is change state of program as it runs. Next, the code organization of object-oriented paradigm is composed of objects that encapsulate data and behavior. Scripting paradigm is composed of a series of commands that are executed in order, and imperative paradigm is composed of a sequence of instructions that the computer executes in order. Now we look at the function of object-oriented paradigm. It creates reusable and modular code by defining objects with properties and methods, while scripting paradigm is automate repetitive tasks or interact with other programs, and imperative paradigm is explicitly specify the actions that computer should take to achieve a desired outcome. Next is performance. The object-oriented paradigm is highly efficient when properly optimized. Scripting paradigm is prioritize developer productivity over raw performance, and imperative paradigm is fine-grained control over memory and CPU storage. Now move on to memory usage of object-oriented paradigm. It can be higher due to overhead of managing objects and dynamic memory allocation. Scripting paradigm can be higher due to dynamic typing and garbage collection, and imperative paradigm is allocated statically or dynamically by direct control of developers. Example of object-oriented paradigm is Java, scripting paradigm is Python, and imperative paradigm is C. First is inheritance. The cat class extends the animal class, inheriting its properties and methods. Second is polymorphism. The cat class overrides the max_sum method inherited from animal. The constructors demonstrate method overloading because they have the same name cat, but accept different number of parameters. Third is abstraction. The animal class is abstract. It cannot be instantiated directly, but it can be used as a base for other classes like cat. Fourth is encapsulation. The properties in the animal class type is encapsulated with the protected access modifier. Similarly, the name and color in the cat class is encapsulated with a private access modifier.
From my perspective, the object-oriented paradigm OOP allows programmers to manage complex software by organizing code into classes with defined relationships, promoting code reusability and reducing complexity through its four pillars: encapsulation, abstraction, inheritance, and polymorphism. While OOP enhances code security and structures, however, it can also introduce performance overhead and complexities, particularly if inheritance is overused or if dynamic language like Python are involved. Overall, OOP is valuable for making code more efficient and understandable, but it requires careful implementation to avoid potential pitfalls.
From my perspective, the object-oriented paradigm stands out because it naturally aligns with the real-world problem solving. I have found that this paradigm's principles, such as encapsulation, inheritance, and polymorphism, facilitate modularity and reusability, which greatly enhance collaboration among developers. Even though the object-oriented paradigms involves complex planning and designing, it offers significant long-term benefits in maintainability and scalability, which effective in overcoming various challenges. Additionally, the consistency of this paradigm across different programming languages and its strong community support further contribute to its productivity and relevance in the modern software development. This paradigm's ability to simplify complex systems into understandable and maintainable components underscores its durability and the practical application. Its versatility spans various domains from website applications to large-scale enterprise systems, demonstrating its adaptability.
From my point of view, the object-oriented paradigm stands out as the most efficient programming paradigm for me. I prefer to use this paradigm because the usage of classes and objects inherently makes the coding structure well organized. Moreover, the concept of inheritance encourages the reusability of code. The attributes and methods of a superclass can be inherited by its subclasses. This can effectively minimize the redundancy of code. Next, the principle of polymorphism allows different objects to respond diversely to the same method call. For instance, method overriding and method overloading. Overriding is a subclass that provides additional methods that are specific to its needs, or that alter the behavior of existing methods in the superclass, while overloading permits the same method name with different parameters to serve varying purpose. Furthermore, the principles of abstraction and encapsulation enable me to hide what should be hidden and make visible what is intended to be visible. By exposing only essential interface and hiding implementation details, maintainable and adaptable system can be created.
In my opinion, object-oriented programming is easy and effective to use because of its ability to minimize software complexity. The concepts of encapsulation, abstraction, polymorphism, and inheritance encourage code reusability, flexibility, and maintenance. For instance, by using the code concept of inheritance. The code from the superclass can be reused in the subclasses, and their properties are inherited to the subclasses. Moreover, polymorphism enables consistent codes as it allows different kinds of objects to pass via the same interface of a common superclass. In addition, encapsulation and abstraction makes code simpler and understandable as it focuses on the essential features of the data. All things considered, OOP offers an excellent basis which makes it crucial for contemporary software development.